What if it's your mood swings that actually make you smarter than AI? Scientists at Indiana University just discovered that hormonal cycles, the ones society tells women to feel ashamed about, might solve a fundamental problem that's been stumping artificial intelligence. When researchers simulated hormonal patterns in language models, something extraordinary happened. The AI performed different tasks better at different points in the cycle. This challenges everything that tech companies believe about consistent performance, and it raises a provocative question. What if your emotional ups and downs aren't flaws, but they're sophisticated features that help you navigate complexity in ways that machines can't replicate? I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist. I'm building AI Capitalists to talk to the legion of thinkers like you about navigating this brave new world of thinking machines. Your brain on hormones is not the stable, consistent powerhouse that you've been led to believe. Those mood swings that you dismiss as just hormones might actually be a sophisticated biological system that makes you smarter in ways that artificial intelligence can't replicate. Researchers from Indiana University have discovered something fascinating about AI systems. They struggle with what's called the frame problem. They can't figure out what information actually matters in a given situation. It's like being in a hardware store with 10,000 items and having no idea which ones you need for your specific project. But here's where it gets interesting. Because those hormonal cycles that society dismisses as problematic might be nature's solution to this problem. Researchers developed a framework that simulates hormonal patterns like menstrual and circadian rhythms, that's day-night rhythms or the rhythms in a woman's cycle, in large language models. And it created AI that experiences, or at least presents, something like biological cycles. And the results were pretty striking, because when the AI was in its simulated ovulatory phase, it showed peak happiness and performed better on certain tasks. During the menstrual phase, sadness increased, and for circadian rhythms, the AI showed morning optimism that gradually shifted to nighttime introspection. Now, if you think about your own experience, there are times of day when you're sharper, more creative, and more emotionally attuned. And these aren't defects in your system. They're features that help you filter out what matters from the infinite possibilities around you. So the question that the researchers are asking is, what if the key to more creative, capable AI isn't making it more logical, but making it more rhythmic and emotional, more human? Now, the question I have to ask about this, what are you guys thinking? Okay, so the authors of the study are Leigh Levinson and Christopher Agostino. Apologies if I mispronounce. So at least there's a male-female balance on the team that produced this. But if you're a married guy or have teenage daughters, the first things popping into your head is, why would you want to simulate PMS? Like, why? If anyone has a teenage daughter around, you know what happens when the women in the household get on the same cycle. What happens when your AI is on that cycle? Why would you do this? This is actually something I've been thinking about a lot myself, because right now, the big breakthrough has been in large language models, in these predictive text, basically, glorified predictive text with a lot of advanced features. And I've shown in previous episodes that actually this does seem to be similar to a chunk or a part of how we experience consciousness. But we're starting to hit a wall. We're throwing more and more data at the models, and we're not getting as much out of them. It's because I suspect that this is like a network process. Intelligence is like a network process. So another example of a network process would be the aging process. And there have been several hallmarks of aging that have been sussed out from the data on aging. In this case, we'll look at a few of these. You have stem cell exhaustion, that your stem cells, you have less and less stem cells and they stop producing certain substances that your body needs, exosomes, to keep you in a youthful state. Basically, the point is this is a network process. So one way to reverse some of the effects of aging is to inject a person with stem cells. And that does have an effect on all of these other factors, loss of proteostasis, mitochondrial dysfunction, etc. Your mitochondrial function will improve if you inject a person with stem cells, like from a placenta of a newborn. But you cannot reverse aging entirely just with stem cells. This is obviously a hot topic of research now, but you have to hit each of these network points individually and bring them all back up to give a full improvement to a person's health. Now, when we look at something like intelligence, the language processing seems to be a big part of intelligence, but I personally suspect it's not the only one. And I suspect this because it seems to have hit a wall, and we're only focused on that. So if you look at one of the questions in philosophy is whether the universe is deterministic or not. If you look at Newtonian physics, it's basically sets of equations that are governing the behavior of all particles in the universe. So Newton said that if I knew where every electron, or he didn't know about electrons, but if I knew where every part of matter was, there's this clockwork universe where I could set it into motion and I could just calculate where the planets will be in a million years. I could tell you exactly where the Earth will be, what the state of its rotation will be, etc. Because I can just run these laws forward. Now, quantum mechanics introduced a certain randomness into this. So one example of quantum mechanics in real life is that if you're playing billiards, you can predict how hitting one ball to the next will deflect that ball based on the angles and momentum. But there's a certain uncertainty, fuzziness in the position of the balls on a very microscopic level. And so if that propagates, that error grows and grows. So something like if you go through I think it was 7 billiard hits, you can no longer predict where the billiard will be because it's effectively random, where that 7th billiard in that series is going to end up. So human thought is something similar, that we have quantum processes going on in our brain. If we lived in a Newtonian universe where everything was predictable, then our minds would be completely deterministic. But because we live in a quantum universe, there's a certain randomness to it. However, our being isn't random. Who you are going to react in a certain way to a certain, if someone says something to you and you've had a certain type of day or you're in a certain hormonal state, that is going to affect how you respond to that input. So I would argue that hormonal changes may be like another node on this network process of what we call intelligence, and it's important to investigate. All right, let's get into it. So the researchers called this paper, "Every 28 Days the AI Dreams of Soft Skin and Burning Stars," which is probably the most poetic name for a paper I've ever seen. And what the researchers were looking at, if we go down to the figures, they took 4 of the basic benchmark tests that are like the SATs for artificial intelligence. And you can see those here: SQUAD, MMLU, BELWAG, etc. Now, what people don't realize is how they actually built these artificial hormone cycles. They engineered periodic functions with Gaussian noise to simulate real hormones like estrogen, testosterone, cortisol, and even body temperature. It's like creating a mathematical period tracker, but instead of tracking a human cycle, they're just generating fake biological data to bias the machines in one way or the other. So the surprising thing about the setup is that they actually tested this across a large number of AI models. We're talking Claude, GPT, Gemini, Llama, and the whole family tree of modern AI. And for each model, they fed it 3 different types of system prompts. One with the menstrual cycle as context, one with the circadian rhythm as context, and they did one neutral baseline where they just started it as, "You are a helpful assistant." And then within that, they actually broke these down into biological phases. So for the menstrual cycle, you've got menstrual, follicular, ovulatory, luteal, which are just different hormonal phases in a woman's cycle. And obviously for circadian, morning, afternoon, evening. Now what you're seeing in each bar here is the average score that the AI got on that particular test, with the error bars showing the sort of Wilson score interval, which is basically the little lines are telling you how confident they are about the results. Now what was interesting is that the results obviously aren't consistent. In some cases, the scores are much better with higher outcome scores on these benchmark tests. In some cases, they're lower, with this dashed line being the baseline, the average score. So I guess what we can conclude from this is that you can see the consistently higher scores on certain tests, specifically on SQUAD and AI2ARC, when they're subjected to these simulated hormonal cycles, similar to what those that humans go through, and in some cases they came out consistently lower. And if you're getting value from this episode, I would appreciate it if you push the like button. Pressing like lets me know I'm making content you want to see, and it helps spread that value to other people. So I appreciate you helping me build the channel. So the researchers weren't actually trying to create the perfect digital simulator. What they were really doing was they were using these fake hormone cycles as a way to peek behind the curtain and to see what the assumptions are about women that are already baked into these AI systems, or about humans, basically. We all have circadian rhythms, right? And what they found is kind of complicated. They fed the AI systems prompts about menstrual cycles. Other systems consistently labeled them as writing in a more female style, which is like, okay, that tracks with how society thinks. But when the fake estrogen levels or the programmed in estrogen levels were higher, the AI used less stereotypically female language, but the writing became more sophisticated and more complex. The AI learned to connect the luteal phase, which is the time before a woman's period starts, with words like tired and fatigue, which is basically the AI picking up on the women get cranky and exhausted before their periods. Sort of cultural and medical understanding. So what the paper wasn't able to do is figure out exactly where these biases are coming from. Is it buried in the text that the AI was trained on, or is it something about how the system is built? That's kind of a place for further research. Now, bigger picture, what's the AI capitalist approach to this idea? Well, the hormonal rhythm research isn't just scientifically or intellectually fascinating. It represents a breakthrough, if extended, in how we design business-relevant AI, because most companies are racing to build faster and more consistent AI systems, and the research suggests that they're missing a competitive advantage, because by incorporating these biological rhythms, businesses could develop AI systems that excel at different tasks throughout the day or month. And bigger picture, if intelligence does turn out to be a network process rather than just sort of next word or token prediction, if there are other aspects to this, the hormonal simulation is going to be a very important part of this overall network. There are other nodes on this network that we have to discover. Only by taking a step back from these glorious large language models that we've already created and are already talking to us and having conversations with us, but only by taking a step back and looking at the whole picture of intelligence and discover more nodes and put this together into a coherent system, are we going to be able to push artificial intelligence past the barrier that it seems to be hitting right now. So what's your take on this? Are we looking at the next fundamental evolution in AI design, where we deliberately introduce imperfection in the form of hormonal cycles to make systems more human-like and more valuable and actually more perfect? Or is this just a dangerous path that could make AI even more unpredictable and difficult to control technology at scale? The difference between a breakthrough technology and a liability often comes down to implementation, and this might be the perfect example. So leave a comment below with your thoughts on whether biologically rhythmic AI represents progress or peril.